big thank you to Odoo for sponsoring this episode. Hello, my name is Joe, and I've got a confession to make. I am a bit of an F-104 fan, to put it mildly, but then who isn't? If I could trace one of the aircraft that sparked my lifelong love of aviation, then a Starfighter would be up there with a few others. I mean, what's not to love? If the English Electric Lightning was Thor's hammer, a beautiful brute of a machine, then the F-104 was a sleek and elegant rapier. One of my earliest memories of the Starfighter was when I saw a photograph of Thor flying in close formation in Italian Air Force colours. Impressionable little Joe thought this was an Italian machine, and even to this day, when I see a Starfighter, I think of Italy, Ferraris, La Dolce Vita, Michael Caine and the Italian job. Well, she did serve with their Air Force for 4 decades, where they upgraded and modified her to the eyeballs. Hence the thumbnail and title of this video, unless I changed them again. This was an aircraft that the US Air Force pretty much gave up on, and by all rights she should have been consigned to the back of a dusty museum and a footnote in history books. But thanks to Lockheed's talent for greasing the wheels and the right pockets, she went on to fly with 15 Air Forces, spawn 21 variants and rack up 46 years of service. However, she was a strict teacher, forgiving only a limited amount of recklessness, high spirits or lack of attention, as many would discover. But in expert respectful hands, she was a glorious lady, and despite the grim nicknames like Widowmaker and the Flying Coffin, all her pilots loved her. As always, I understand that the F-104 has been covered by other creators, but this is my take on her story, based on all the books and articles I have read, plus the many pilot interviews I have listened to about the Starfighter over the years. So, put the kettle on, make yourself a nice cup of tea, slip on your aviators, and let's get cracking. This is the story of the superb 104 Starfighter. It's easy to forget that even before piston-powered fighters fought in the skies of Europe, that the British and Germans were already tinkering with jet propulsion. On the 27th of August 1939, just days before the outbreak of World War II, the Heinkel HE-178 took to the air piloted by Erich Warsitz and powered by a Hans von Ohain's HS-3B turbojet engine. It was the first aircraft in history to fly solely under jet power. Very soon the British followed suit. On the 15th of May 1941, the Gloster E-28/39, powered by Frank Whittle's centrifugal flow W1 jet engine, made its maiden flight. While it is claimed that American officials remained unaware of Heinkel's first flight, Major General Henry Hap Arnold, Chief of Staff of the US Army Air Corps, was shown the extent of Britain's jet program when he attended a demonstration of the Gloster aircraft during a visit to the UK in April 1941. Arnold was suitably impressed by what he saw, and he swiftly laid out America's jet future. In the immediate term, Arnold moved quickly to secure the British jet technology, arranging for the State Department to initiate discussions with the government in London regarding the transfer of Whittle's engine along with its plans and specifications to the US. In September 1941, only 3 months before the US entered the war, Bell Aircraft Corporation was chosen to design and build the first American jet. General Electric's Lynn, Massachusetts plant was tasked with reverse engineering the Whittle W1 jet engine, which had been flown over in a bomb bay of a B-24 to create the first batch of 15 engines. The American jet aircraft program was shrouded in such secrecy that, to disguise its true nature, the new aircraft was designated the XP-59A, suggesting that it was merely a continuation of the cancelled Bell XP-59, a propeller-driven twin-boom design. The XP-59A began ground testing at Muroc Dry Lake, California, with short hops on October 1, 1942, flown by Bell test pilot Robert Stanley. The next day, Colonel Lawrence Craigie completed the first full flight. Despite hopes for production, the XP-59A and the subsequent P-59A/B variants offered no real advantage over propeller-driven fighters and were relegated to test and training roles. At this point, the Army turned to Lockheed. Bell was ordered to hand over its advanced turbojet research, but Lockheed opted to pursue its own ideas rather than continue Bell's work. In May 1943, officers from the Army Air Force's Engineering Division at Wright Field briefed Lockheed executives on jet propulsion developments. They asked the company to produce a new jet fighter using the British engine, detailed plans for which had been delivered to Lockheed just 2 months earlier. Lockheed was certainly not new to the jet game. The company had already been engaged in significant development work on turbojet engines and had proposed the L-133 jet fighter, an exotic aircraft featuring a blended wing body canard design and powered by a pair of Lockheed L-1000 axial flow turbojets designed by Nathan Price. As a side note, in 1942, although the L-1000 turbojet was technologically more advanced than the centrifugal flow engines of the time, it was also more complex and challenging to manufacture. The story of the L-1000 could make a video all on its own, but I'm not the guy for that. In any event, in 1943, the United States Army Air Force transferred development of the L-1000, now designated the XJ-37, to Manasco Manufacturing Company and to the Wright Aeronautical Corporation. In response to America's need for a viable jet fighter, Lockheed moved at astonishing speed. On the 17th of June 1943, just 2 days after submitting a proposal, the company received a contract to develop what would become the XP-80. Lockheed's chief engineer, Hibbard, immediately tapped Clarence Johnson to lead the project. Johnson quickly assembled a tight-knit team housed in a makeshift facility in Burbank, California, which was right next to a smelly plastics factory. Working under intense wartime urgency, 10 hours a day, 6 days a week, the team completed the XP-80 prototype ahead of the 180-day target. This feat would later become the model for Lockheed's legendary Skunk Works division, and it defined Johnson's approach of be quick, be quiet, and be on time. Designated the L-140 internally, the XP-80 was a sleek single-engine jet fighter with a tricycle undercarriage, a bubble canopy for all-round visibility, and 650 caliber machine guns concentrated in its nose. It was powered by a British Halford H-1B turbojet, however jet engine limitations ultimately reduced its performance from a projected 3,000 pounds of thrust to approximately 2,500. The first flight took place on the 8th of January 1944 with Lockheed's chief test pilot Milo Bertram at the controls. Despite minor issues on the first hop, Bertram was soon performing aerobatics to the amazement of onlookers. The prototype, nicknamed Lulu Bell, impressed with its speed and handling, even if it wasn't flawless. Lockheed quickly followed with 2 improved prototypes, the XP-80As, incorporating pressurized cockpit, greater fuel capacity, and other refinements. These were completed with a similar urgency. The first, Grey Ghost, rolled out after 132 days after work began. Despite early teething problems, including engine failures and flight handling quirks, the XP-80A proved tactically superior to all contemporary piston fighters in US service, and was given the same production priority as the B-29 bomber. With the P-80A solidly established in production, Kelly Johnson's team at Lockheed began exploring next-generation jet fighter concepts in mid-1945. But after losing a contest to win a contract to develop a penetration fighter in 1950 to the XF-88, which was later developed into the F-101 Voodoo, Lockheed shifted its focus to all-weather interceptor studies in response to a 1950 USAF request for proposal. Before we dive into the story of the F-104, a quick word on how I make these videos. As you can probably tell by the length of this episode, it was a beast to make. Dozens of sources, a mountain of notes, and far too many ideas flying around. In the past, I used a combination of my trusty corkboard, a basic text editor, to juggle everything. Ideas, resources, quotes, book page numbers, URLs, narration drafts, and trying to keep track of what was done and what still needed doing. Well, it was organized chaos, and it chewed up more time than I could afford. That's where this video's sponsor Odoo came to the rescue. Odoo is like a Swiss army knife for getting things done. Whether you're running a business, managing a team, or just trying to stay on top of a big creative project. Odoo has apps that help you plan, track, and organize without needing a dozen disconnected tools. And the best part, you can start with one app completely free, forever with unlimited support and hosting included. For this F-104 episode, I use their project app, and it's completely transformed how I work. With it, I can break my videos into stages, sort them by priority, and even assign tasks to team members if I had any. Getting started is easy. Click New, give your project a name, create stages for each step of your process, add tasks, set deadlines, assign priorities, drop in subtasks, links, notes, even schedule emails or calls straight from the task. It's like mission control for creative chaos. For this F-104 video, Odoo helped me spend less time digging through piles of notes and more time actually writing and researching. Now it's a permanent part of my workflow. And remember, the best part, Odoo project is completely free, forever, for one app, with unlimited users. They've also got CRM, e-commerce, and many more, all on one centralized platform. And because every app talks to each other, you'll save even more time. So whether you're juggling a YouTube channel, managing a team, studying for an exam, or launching your next business idea, it's all much easier with Odoo. So click the link in the description and give Odoo project a try. Thank you to Odoo for sponsoring this video. Now back to the story. In true Lockheed fashion, their design, the L205, which many claim is the missing link between the XF90 and the F104, was a sleek-looking machine and was expected to achieve supersonic speeds with its single 15,000-pound thrust General Electric XJ53 afterburning turbojet. Interestingly, it also had a semicircular dorsal intake, very much like the future North American F-107A. Lockheed managed to win the competition for the all-weather interceptor, with the Air Force ordering 2 prototypes. With the contract in hand, the design was redesignated the Model 99, and detailed engineering work began. Armament was expected to have included 6 MX-904 air-to-air missiles stowed in the fuselage bay, plus 20 2.75-inch rockets mounted externally. However, as weight estimates began to creep up and projected performance numbers started to dip, confidence in the design was faltering. Nevertheless, before a prototype was even built, the Air Force pulled the plug in January 1951. And then later that year, the Air Force dangled another contract, this time for a large twin-engine J-67 powered interceptor, but it came with a poison pill: a patent forfeiture clause. The USAF insisted on the condition that Lockheed relinquish all patent rights on their next design and permit the government to assign the production of the new aircraft to other firms if it so chose to. Lockheed naturally declined to bid, but there was another reason for turning down the potential contract. At the time, in the United Kingdom, William Teddy Petter at Folland had begun working on a lightweight fighter, which resulted in the Folland Midge and Gnat, video link in the description. While in France, several new Interceptor Léger or light interceptor projects were underway, which included the 1402 Gerfaut, the SE-212 Durandal, the SO-9000 Trident, and the MD-550, the forebearer of the superb Mirage series. In the United States, Ed Heinemann of Douglas attempted to interest the Navy in a light fighter, but instead secured a contract for a light attack aircraft, which became the famous A4 Skyhawk. At the same time, in 1952, Johnson had been invited to travel to South Korea by Chief of Material Command Lieutenant General Benjamin Chidlaw, who wanted the aircraft designers to understand how their aircraft were performing and what fighter pilots needed in combat against the enemy. While there, Kelly Johnson visited numerous air bases and spoke directly with US Air Force F-86 pilots. When asked what they wanted, their wish list was pretty unanimous. They needed a lightweight, high-performance daylight air superiority fighter, one that could outmatch the MiG-15 and would outclimb, outmaneuver and outpace anything the Soviets would field, maintaining a clear edge well into the future. Pilots were also clear about what they didn't want. They didn't want radar, no complex gun aiming equipment, no heavy avionics, and no added weight from non-essential systems. Colonel Francis Gabby Gabreski, a leading ace from both World War II and Korea, dismissed radar outright, remarking, "I'd rather sight with a piece of chewing gum stuck to the windscreen." Just point and shoot, basically. While the F-86 Sabre is often regarded as the better overall aircraft, especially after US pilots were able to study a MiG-15 in detail following the defection of Lieutenant No Kum Suk, the comparison wasn't entirely one-sided. In several key performance areas, the MiG held the advantage. It could climb faster, accelerate more quickly, and reach a higher operational ceiling than a Sabre, from which the Soviet, the Chinese, and North Korean pilots would taunt the Americans to come up and engage them. At its core, the main difference between the two was weight. The MiG-15 was simply lighter, which gave it an edge in raw performance, even though the Sabre typically came out on top thanks to superior pilot training, better systems, and more refined handling. When Johnson returned to Burbank in November 1952, influenced by his experience in Korea, he began work on a clean-sheet air superiority day fighter that would fly higher and faster than anything flying anywhere, and he would do this despite there being no official USAF requirement at the time. What the pilots told him convinced him to go for all-out performance at all costs. Unlike the fallen Gnat, it would be stripped to the bare bones. It would be effectively a hit-and-run machine. But what shape would it take? Fortunately, the Lockheed team had access to a growing pool of classified supersonic research from both the Air Force and Navy, including data from NACA wind tunnel work. A key source of data was from the Douglas X-3 Stiletto program, a research aircraft designed to study sustained supersonic flight. Findings from the X-3 testing confirmed that for speeds above Mach 2, the optimal wing design was categorized by being short, thin, and unswept, but the challenge was to manufacture such a wing without sacrificing structural integrity. Lockheed was already working on its L246 concept, which would in time become the Model 83 and ultimately the F-104. This was a clean, lightweight fighter with extremely thin, straight wings to minimize drag. The thin wing design helped eliminate common high-speed issues such as buffeting and Mach tuck at transonic speed. Or in other words, the thin wing would prevent the tendency for the nose to pitch down due to a change in the center of pressure as the shockwave moved rearward along the aircraft. However, it introduced significant structural challenges. At high speeds, deflecting the ailerons could twist the wing, creating aeroelastic stresses that might lead to failure unless the structure was exceptionally strong and rigid. At the time, Lockheed lacked a wind tunnel capable of going to Mach 2, so to solve this problem, Johnson made a few calls. One in particular was to the head of Air Research and Development Command in Baltimore, to a Lieutenant General Earl Partridge. Johnson described to him the problems they were having in testing the thin wing as well as the tail and air intake ducts for the new fighter. According to Johnson's biography, after the conversation, General Partridge sent a message to Korea: stop shooting rockets for one morning and send them all to Kelly. 2 weeks later, 460 rockets found their way to the Skunk works at Burbank. Now with these rockets at their disposal, they took them to the open grounds of Edwards Air Force Base, where they were kitted out with cameras and telemetry gear. They then fitted the rockets with one of the hundreds of different wing and tail designs, each one with a particular stiffness, shape or structural tweak, and fired at speeds reaching 1500 miles per hour. Soon they had all the necessary data for the team to start designing a wing that was built around a solid aluminium alloy core, where both the longitudinal and transverse members were machined from a single slab to maximize strength. The outer skin was made from aluminium and, from what I have read, was half an inch thick at the wing root, tapering to a quarter of an inch at the tip. Lockheed also made the deliberate choice to bolt the F-104 wings directly to the fuselage using heavy forged fittings, rather than use a traditional design where the wings pass through or beneath the body. Each wing was positioned towards the rear of the aircraft for aerodynamic reasons, plus attaching them like this avoided interference with the engine. That's not to say that Johnson didn't explore other wing or even tail configurations. In the early 1950s, most supersonic fighter design leaned towards swept or delta wings to reduce drag at high speeds. Swept wings were especially effective in the transonic range, roughly between Mach 0.8 and 1.2, because they delayed the onset of shock waves that caused wave drag. However, to generate enough lift, swept wings had to be relatively long and thick, which added drag at higher Mach numbers and reduced overall agility. Delta wings, with their large triangular shape, managed drag well in the transonic range, making them a good choice for aircraft like the F-102 and F-106. Their shape delayed shock waves to help maintain performance through the sound barrier. However, delta wings produce less lift per square foot than straight wings, requiring larger wing areas to carry the same weight, which could increase drag at lower speeds. While some delta-wing fighters like the F-106 could exceed Mach 2, they often needed more power or larger wings to sustain high supersonic speeds compared to the F-104's design. Kelly Johnson and the Skunk Works teams decided to go a different route with the F-104. They designed a short, razor-thin, trapezoidal-shaped wing with a downward tilt, or anhedral, to improve roll performance and a 20-degree swept leading edge. Personally, I've always found the anhedral design quite elegant looking. These wings had a thickness to chord ratio of just 3.36%. At the root, the wing was just 4.2 inches thick and just under 2 inches at the tip. But because the small surface area of just 196 square feet meant that the wing loading would reach up to 105 pounds per square foot on later models like the G, which meant that Lockheed had to build wings strong enough to survive those extreme forces. To pull it off, they used cutting-edge techniques including chemical milling that removed material with surgical precision and zero-draft forging, which shaped structural parts without compromising strength. If you really want to geek out, look up chemical milling and zero-draft forging so you can bring it up at your next family barbecue. Hey, while you're flipping those burgers, did you know Lockheed used acid to sculpt the Starfighter's wings? No? Well, let me tell you something. One of the most notable features of the wing is the leading edge, which, according to Kelly Johnson's book, More Than My Share of It All, was about as thick as a pair of razor blades. Lockheed Folklore went a step further, claiming it was sharp enough to cut steak, though whether anyone tried is unknown. The fact is that the edges were considered dangerous enough to the ground crew that Lockheed issued special covers to prevent harm or damage to equipment like fuel hoses from being cut, and naturally to avoid any unwanted decapitations. But on a serious note, they were also covered to prevent any damage to them, as any dent or ding would disturb the airflow. But as you can see, the leading edge is no sharper than the edge of a metal propeller blade, so although the leading edge is comically thin, even by fast jet standards, you can run your hand along it, but I wouldn't want to run into it for sure, and just be careful not to bump your head on it when you're crawling around the airframe like I did. Although those stubby wings just 21.9 feet from tip to tip sacrificed low speed lift and handling, they did allow the F-104 to accelerate through and beyond Mach 1.5 with relative ease. Plus, they made the aircraft incredibly stable, which meant that it didn't get tossed around by gusts or turbulence when flying fast and low, where it was said by pilots to be a solid ride. But with a wing area of just 196 feet, it meant that the F-104 couldn't pull off tight turns. As one pilot joked, turning took the whole state of Texas. But that didn't matter. It was designed to do to MiGs what they had done to the F-86, only even harder. So as a close-in dogfighter, where it was expected to fight in a phone booth, the F-104 had clear limitations due to its small wings, high wing loading and poor rate of turn, meant that it couldn't outturn most opponents, but as a hit-and-run energy fighter, it was perfect. As a quick aside, there are one or two claims that I have read that the F-104 could sustain turns at a better rate than the MiG-21 at certain speeds, i.e. above 400-450 knots, but I'll leave that to the experts, so if you know, please leave a comment. I'd like to find out if this is true or not. The F-104 could employ slash and run or yo-yo attacks from high altitude, swooping down to make a pass, engaging with its cannon, and then extending vertically and repeating the process, whereas aircraft like the F-4 had to turn and burn. Additionally, its small radar cross-section allowed the Starfighter to sneak up on opponents. Check out Project Feather Duster, a 1965 USAF evaluation simulation that simulated combat against F-86s, F-5s and F-106s standing in for MiGs. The F-104C surprised many by performing far better than expected, thanks to its powerful engine and energy retention, especially above 300 knots. The aircraft's tail was as equally unconventional as its wings. Most jets at the time used traditional horizontal stabilizers mounted low or midway on the vertical fin. But wind tunnel and rocket testing showed that for the F-104's speed range, the best pitch control and stability came from placing the tailplane at the top of the vertical fin, creating the now familiar T-tail. This all-moving tail or stabilator pivoted as a single piece rather than using separate elevators, which gave the pilot better control authority at high speeds and altitudes. That said, the design wasn't without its issues. The airframe of the Model 83, as it was now known, was a tightly engineered package where every component had to earn its place. There was no room for excess weight or bulk. Its design focused on minimizing drag and maximizing performance at high speeds and altitudes, and that philosophy extended all the way through the structure of the aircraft. Internally, the fuselage was divided to house flexible bladder-type fuel cells that conformed to the aircraft's shape. These bladders were mounted along the centerline and offered decent fuel volume without the added weight of complex tanks. Other key systems, such as the avionics, were packed into a compartment located just behind the cockpit and referred to as the E-bay or electronics bay. Structurally, the Model 83 used a semi-monocoque construction, a method common in aircraft where the outer skin and internal framework share the load. Materials were carefully chosen: aluminium where lightness was needed, stainless steel where strength and heat resistance were critical, and titanium to withstand both mechanical stress and the intense heat produced by the afterburner. In pursuit of weight savings, Lockheed's design team made a critical trade-off. They eliminated the heavy cabin pressurization system. Instead, the pilot wore a bulky pressure suit, essentially a partial spacesuit, which was notoriously uncomfortable but necessary. In the end, Johnson and his team had produced an aircraft that on paper weighed just under 1,150 pounds empty. That was literally half the weight of most competitors were proposing at the time. However, this would eventually balloon to almost 30,000 pounds maximum takeoff weight in the later G version. So even though there was no formal requirement from the United States Air Force at that point, Johnson decided to push ahead and he submitted an unsolicited proposal to the Pentagon in January 1953. Despite the design going against the USAF doctrine for all-weather long-range fighters, he showed his design to General Don Putt and Colonel Bruce Holloway, who were immediately impressed by the radical-looking aircraft, so much so that Holloway reportedly said, "Well, if there isn't a requirement, I'm going to make one. Stick around, Kelly, come back in a couple of hours." Holloway then wrote a page and a quarter on what the Air Force required for its next fighting aircraft. It should be lightweight, capable of performing specific tasks at both sea level and high altitudes, and carry particular armament, radio and other specialized instrumentation. A little while later, Holloway handed over the specs. "Here are your requirements," Johnson was told. "Go and see what you can do with this." Shortly after, the Air Force issued a formal set of specifications under Weapon System 303A, and the successful design would either support or replace the F-100 in Tactical Air Command beginning in 1956. By January 1953, Lockheed's design had beaten out the Northrop N-102, North American NA-211, and the futuristic Republic AP-55 Thunder Warrior. Some say it was due to the firm already having a head start and the requirement being written specifically for them. Shady dealings, maybe. Was this a sign of things to come? On March 12th, a contract for 2 XF-104s was issued. What started as a private venture for Lockheed now looks set to land the ultimate prize, becoming a part of the USAF's future front line. However, in July 1953, the war in Korea ended, and suddenly the need for a daylight air superiority fighter was no longer a priority for the US Air Force. So, rather than throw the baby out with the bathwater, Lockheed repositioned the XF-104's mission from a pure air superiority fighter to one of an air defense interceptor, and it wouldn't be the last time that Lockheed would change the aircraft's intended role. This shift aimed to align the XF-104 with the previously mentioned emerging USAF priorities, particularly for a rapid response interceptor during the early stages of the Cold War. Lockheed hoped this pivot would enhance the XF-104's appeal by presenting it as a flexible multi-role platform, one that could serve effectively in the interceptor role while retaining the capability to perform air superiority missions if required. And just like the F-104, from here, things would move fast. I want to take a second here to thank you so much for watching. I'm truly grateful to share my love of aviation with fellow enthusiasts like you. So if you're enjoying this story, please take a quick second to hit the like button. It's a small gesture that makes a huge difference in helping me reach more aviation fans. Now, let's get back to the story. The big question was what engine the XF-104, as it was now designated, would use. There were a few options on the table. First there was the Allison J71, projected to make around 14,000 pounds of thrust with afterburner. However, the Pratt & Whitney J75 looked even better on paper, producing up to 21,000 pounds of thrust depending on the variant. And then finally, General Electric's new J79, which was expected to deliver about 15,000 pounds of thrust with afterburner, again dependent on the variant. Early jets like Lockheed's own F-80 Shooting Star used centrifugal flow engines, basically spinning the air outward from the center before compressing and igniting it. But that design didn't scale well for high-speed, high-thrust applications. What Lockheed needed for the XF-104 was an axial flow turbojet, where the air moves in a straight line through a series of compression stages before fuel is added and ignited. Ultimately, Johnson wanted the J79. It was a genuinely revolutionary engine. It was the first US single-shaft, high-performance axial flow turbojet with adjustable guide vanes. Now, the key innovation was the variable stator vanes, which allowed the engine to adjust the airflow internally. This increased compressor pressure and crucially was supposed to help eliminate compressor stalls, a huge problem back then, especially when trying to go supersonic. The holy grail at the time was a jet engine that was lightweight, powerful, fuel efficient and mechanically simple. All the engine manufacturers claimed they were close, but the J79 came closest. At just 3,500 pounds dry weight and producing more than 15,000 pounds of thrust, its thrust to weight ratio was unmatched, and it had better specific fuel consumption than either the J71 or the heavier first-year J75. Crucially, the J79 was the first American production engine designed from the outset to sustain flight at Mach 2. But as always, there was a catch. The engine didn't just roll off the production line ready to go. Like all new technology, it had to go through a painful development cycle filled with teething problems, reliability issues and all the usual drama. In fact, the J79 engine wasn't even run on the test bench until mid-1954. But when it did finally run, it made a wonderful sound, an unearthly shriek during the run-up. The sound was nicknamed the Moose Call, apparently caused by the inlet guide vanes rapidly repositioning. And then during landing, it made that moaning sound that sounded like a wounded banshee. Right, back to the story. So rather than wait for the J79, Lockheed fitted a prototype with a Buick-built Wright J65W6, a license-built version of the Armstrong-Siddeley Sapphire axial flow turbojet. This meant that Lockheed had to design two different airframes, one for the J65 and the other for the J79. So the first of the two prototypes was fitted to the J65W6 engine, rated at 7,800 pounds dry thrust or 10,200 pounds with afterburner, although this was still just 70% of the power expected from the J79. Interestingly, the prototype fitted with the J65 had smaller intakes that lacked the iconic shock cone or the ventral fin, and the XF-104 was also shorter, measuring just 49 feet 2 inches compared to the later Starfighters, which measured 54 feet and 8 inches. Early on, Lockheed engineers had a serious concern. If the pilot had to eject at high speed, would he even clear the Starfighter's massive T-tail? At nearly Mach 2, with the old-style ejection seats, the answer was probably no. The seat simply didn't have the thrust to launch the pilot up and over that tall vertical stabilizer. That meant one thing: an upward ejection could send the pilot straight into the tail, and fitting more powerful rockets to compensate wasn't an option either. There are limitations on how hard you can eject the pilot upwards, or they won't have a spine when it's over. So until better ejection technology came along, the only viable solution was to go down. To that end, Lockheed made a canopy non-jettisonable and fitted the Stanley C1 ejection seat to fire down through the cockpit floor. Engineers reasoned that most ejections would happen at medium or high altitudes, where a downward firing ejection seat would safely clear the jet. Once the pilot pulled the ejection handle, the cockpit depressurized, explosive bolts blew a hatch off the underside of the fuselage, and the seat fired down and out of the aircraft. But as you can imagine, this wasn't much use on the ground, or even at low altitude. In a low-level emergency, the only real option was to roll the aircraft inverted and eject upwards through the bottom of the jet. Unsurprisingly, this system had a pretty poor survival rate. Around 21 pilots were killed attempting to use a downward firing seat, including X-2 test pilot Ivan Kinchlow Jr., who died in 1958 after ejecting too low from an F-104. The C1 seat also had a quirky feature that earned the F-104 pilots the nickname Cowboys. Before takeoff, pilots would slip on a pair of metal spurs onto their boots that clipped onto a ball connected to a spring-loaded cable attached to the footrests of the seat. When the seat was fired, the wires would automatically yank their feet inwards, keeping their legs tightly against the seat to prevent them from flailing, or worse on the way out. Not exactly confidence-inspiring, but that was the state of the art at the time. But from the F-104C models onwards, they would be fitted with upward-firing ejection seats. Other novel engineering was found throughout the aircraft. To drive the outboard ailerons, Lockheed devised so-called piccolo actuators, which contain a row of 10 small hydraulic rams in a solid block of aluminium fitted within the available depth of 1.1 inches. To enable the tiny wing to generate sufficient lift at reasonable takeoff speeds, the leading edge was hinged to pivot downwards under electric actuation, in one of the world's first droop-snoot configurations. For landing, even more radical measures were necessary. The F-104 was the first production application of the boundary layer control blown flap, which John Antinello had just devised. This system took hot, high-pressure air bled from the engine and blew it through narrow slits ahead of the upper surface of the flap, preventing flow separation when the electrically operated flaps were rotated down. With the trailing edge flaps and leading slats rotated to 45 degrees, the landing speed was reduced by an impressive 30 knots, but it was still an eye-watering 175 knots on final approach. The British Doughty Company provided liquid spring shock struts which were small enough to cushion the shock of landing on the small main landing gear. What looked like the magic of origami, the main undercarriage rotated and pivoted into the fuselage. As you can see here in the video. Thank you to Piercarlo for allowing me to use his footage. Go check out his channel, link is in the description. There's lots of F-104 action there. So mille grazie per il tuo aiuto, Piercarlo. For those of you curious about the small hatch that kept opening on the side, it's called a blow-in door and is used to prevent differential pressure from building up between the engine compartment and the outside. That long nose cone was made from wound fiberglass to make it electrically transparent, and nose pointy enough to satisfy even Admiral General Aladdin.
It is too round on the top, it needs to be pointy.
Initially, Lockheed had wanted to arm the aircraft with a pair of 30mm cannons. Still, these were replaced with the revolutionary new gun developed by General Electric, a rotary 6-barreled M61 Vulcan cannon, which fired 6,000 shells a minute from its 6 barrels. The first XF-104 prototype, 537786, was rolled out from the Lockheed plant in Burbank, California on the 23rd of February 1954 and was quietly trucked to the top-secret test area at Edwards Air Force Base in the Mojave Desert the following evening. Tony Levere, Lockheed's test pilot, who according to Kelly Johnson, when he first laid eyes on the F-104, asked, "Where are the wings?" Once the aircraft had been readied, they began ground taxi tests in the X-104 on the 27th of February 1954. Just one day later, on the 28th, he gave it a quick hop off the runway. Nothing dramatic, just a gentle lift and set down to see how it behaved. That short hop went well enough, and with confidence building, the first official flight followed on the 4th of March. But the optimism didn't last long. Almost immediately after takeoff, Levier discovered that the landing gear refused to retract. Not ideal, but also not a disaster. Certainly better than it retracting and then refusing to come back down. On the second flight though, it was deja vu, same issue, the gear stayed stubbornly down. It wasn't a systems failure as much as a teething issue, early hydraulic teething at that. Between ongoing engineering fixes and bouts of poor weather at Edwards Air Force Base, the F-104 didn't get back into the air until late March. During early armament testing on December 17, 1954, Tony Levier experienced a dramatic malfunction in the second F-104 prototype. While firing the M61 cannon, a round detonated in the breech, launching the bolt rearward through the bulkhead into the fuel cell behind the gun bay. Fuel leaked into the gun bay, and with the cockpit filling with smoke, Levier had two options: bail out or stay with the aircraft. He decided that ejecting at 50,000 feet would mean that he would freeze to death before he got to the ground, so he elected to stay and get back to base 50 miles away. As he neared the base, the engine failed along with the flaps. Despite this, he managed a dead stick landing on Rogers Dry Lake. As somebody once put it, the aircraft managed to shoot itself down. On the 14th of April 1955, Lockheed test pilot Herman Fish Salmon was flying the second F-104 prototype around 47,000 feet, conducting high-altitude supersonic gun-firing tests with the Vulcan cannon. During the firing run, accumulated gas from the gun assembly blew open the ejection hatch door in the cockpit floor, although some accounts suggest that it was one of the landing wheel well doors. Regardless, this caused a sudden explosive decompression. Fortunately for Salmon, he was wearing a pressure suit. The sudden decompression and blast of freezing air froze over Salmon's faceplate almost instantly. At the same time, the pressure suit's internal air bladders inflated, pushing his helmet upward on his head. The cockpit quickly filled with dust, fiberglass insulation and other loose debris, further reducing his visibility both inside and outside the aircraft. And to make matters worse, the tight pressure suit severely restricted his movements. With his visibility dropped to near zero and no clear view on what had gone wrong, and recalling a similar gunfiring issue Tony Levier had encountered months earlier, he assumed the worst. He throttled back, deployed his speed brakes and began a descent, hoping to recover, but by 15,000 feet he still couldn't see. Almost out of time and options, he elected to eject. The downward firing seat blasted him out around 250 knots. He landed safely, although injured. That marked the loss of the second F-104 prototype. According to Johnson's biography, Herman wanted to help gather as many answers as possible to determine the cause of the accident. Some versions say that he volunteered to be injected with sodium pentothal, or in layman terms, a truth serum, though there's no trace of it in official records, so we'll leave that one as Cold War aviation legend. However, they were soon able to determine precisely what happened, and the gunfiring problem was quickly resolved. And for making it this far, have some more jet noise. Despite the loss of the one F-104 prototype, the Starfighter program pressed ahead. On March 30, 1955, the Air Force awarded a contract for 17 pre-production aircraft designated YF-104A, with serial numbers ranging from 552955 to 552971. These aircraft were used to support flight testing and the development of the General Electric YJ79GE3 engine, which was expected to be capable of producing approximately 14,800 pounds of thrust and afterburner. The F-104 became one of the earliest production fighters to incorporate a variable area exhaust nozzle with hydraulically operated pedals that adjusted automatically with altitude and airspeed. This allowed for more efficient engine performance across a broad flight envelope. By this stage, the YF-104A had adopted what would become one of the most distinctive features: fixed half cones within the engine inlets. These were designed to help manage supersonic airflow by positioning shock waves more effectively. Unlike later supersonic aircraft that employed complex variable geometry inlets with moving cones or ramps to adjust airflow dynamically, the F-104 relied on a more straightforward solution. Its sharply swept wedge-shaped inlets created oblique shock waves to slow incoming air before it reached the engine. While this fixed design simplified construction and reduced mechanical complexity, it came at a cost of efficiency at the very highest Mach numbers. It would have been interesting to see how the F-104 would have performed if those cones were movable. The airframe evolved too. The fuselage was stretched to 54 feet 8 inches, tail surfaces moved aft and more fuel was added. The nose gear was reworked to retract forward, making room for the downward firing ejection seat, and the electrical power was more than doubled. The first YF-104A rolled out on December the 23rd, 1955, and just 2 months later, on February the 17th, 1956, Lockheed test pilot Herman Fish Salmon flew it for the first time, making it one of the first aircraft to fly with the J-79 engine. Less than 2 weeks later, on February 28th, Joe Osier took it past Mach 2 in level flight, an official 1,320 miles an hour. Then very soon after, in March 1956, the USAF placed an order for 7 pre-production F-104As. That same contract approved a full production run comprised of 146 F-104As and 6 tandem-seat F-104Bs for the Air Defense Command. In the end, 2 of the YF-104As were reclassified as production jets, bringing the final numbers to 15 pre-production YF-104As and 155 production F-104As. Tactical Air Command jumped in too, ordering 56 F-104Cs to meet their requirement for a supersonic strike fighter. The F-104C was essentially an upgraded F-104A, modified to carry both conventional air-to-ground ordnance and nuclear weapons. It would have an improved fire control system and a detachable air-to-air refueling probe to extend its operational range, and be powered by the J-79 GE-7 engine. The F-104A Starfighter's public debut occurred on April 17, 1956 at a press event hosted by General Otto Wayland of Tactical Air Command. Interestingly, to conceal classified inlet features, Lockheed used fake inlet fairings, a typical Cold War tactic. The F-104A was initially equipped with the J-79 GE-3A engine, which produced 9,400 pounds of dry thrust and 14,800 pounds of afterburner. This upgrade gave the A model a maximum speed of Mach 2 and a ceiling of 57,750 feet. More on this engine and its issues a bit later. Armament-wise, the A model could carry 2 wingtip-mounted AIM-9B Sidewinder missiles with the AN/ASG-14T1 fire control system, a drag chute that the pilot operated by pulling a small handle in the cockpit as shown in the video, and in some cases a runway arrestor hook. The onboard fire control system included a radar ranging gun sight and basic radar, providing limited target detection beyond visual range. However, the F-104A was still a day fighter, no question. Stalls and spins were a serious weak spot for the F-104 Starfighter. Its high-mounted T-tail made it prone to pitch up at high angles of attack. Once that kicked in, the aircraft would start to oscillate violently, dropping thousands of feet before the pilot could recover, if they could at all. In rare cases, the wild gyrations stretched the airframe to the point of failure, although high G loads were usually the bigger culprit. The Starfighter could stall fast and with little warning, especially during abrupt maneuvers. Even small control inputs could push it beyond the safe angle of attack. At supersonic speeds, the situation worsened. There were no natural stall cues, no buffet, no warning signs. To address stability concerns, Lockheed equipped the F-104 with an automatic pitch control system. This system measured the aircraft's angle of attack using an external sensor with the data displayed on a cockpit gauge. As the angle of attack approached the critical threshold, marked in red on the dial, the APC would issue a tactile warning by vibrating a control stick. If the angle continued to increase into the danger zone, The system would actively intervene, pushing the stick forward to lower the nose, which would trigger before the stall occurred. Pilots were trained to recover at the first sign of a shaker or kicker activation. From what I have read and heard, stalls were never practiced below 25,000 feet. Spins were a whole other beast. They weren't just discouraged, they were banned. Intentional spins were prohibited because recovery was unreliable or flat out impossible. The pilot handling manual even stated that a spin revolution would result in a loss of altitude of between 1800 and 2000 feet, with each revolution taking 5 to 6 seconds and producing a rate of descent of around 18,000 feet per minute. The manual also states that the aircraft should be abandoned if rotation has not stopped by 15,000 feet. When taking altimeter lag into account, the pilots would have had only moments to decide whether to step out and hang up the for sale sign or attempt to recover from loss of controlled flight. However, reading the pilot notes for the F-104, most of the checklists for an emergency concluded with the advice to eject. If you're interested, I've put a link in the description to the pilot notes for the F-104D. If there's one thing aircraft manufacturers love, it's showing off. Flying higher, faster and louder than the competition, and a Starfighter, she was no exception. The F-104 has the distinction of being the first aircraft to hold both the world speed and altitude records. If you've ever watched the film The Right Stuff, you get the idea that the F-104 will climb like a rocket at around 48 to 50,000 feet per minute, but more on Chuck Yeager later on. On the subject of films, I challenge any of you to sit through the entirety of the 1964 film The Starfighters. It's almost unwatchable if it were not for the F-104s. Anyway, the F-104A entered operational service with the USAF in February 1958 when the 83rd Fighter Interceptor Squadron at Hamilton AFB, California received its first AF-4A Starfighters, and it was not long before they started setting world records. On May 7, 1958, USAF Major Howard Johnson, operations officer for the 83rd, flew an F-104A from Edwards Air Force Base to set a new official world altitude record. Johnson first climbed to 41,000 feet, reaching a maximum speed in level flight before pulling up into a 2.5 G zoom climb. To ensure that he had the optimum climb angle, he had stuck a strip of tape on the canopy to help him maintain the correct attitude. At around 77,000 feet, he shut the engine down to avoid overheating in thin air. From there, the Starfighter continued upward, coasting on momentum alone, on a ballistic trajectory, arcing to its peak altitude before starting its descent back towards Earth, where he restarted the engine and landed back at Edwards. His record of 91,243 feet surpassed the one set just 17 days earlier by a Navy pilot flying a modified F-11 Tiger, outclimbing it by more than 14,000 feet, earning its "missile with a man in it" reputation. Then on the 14th of December 1959, Captain Joe Jordan climbed aboard an F-104C at Edwards AFB, his goal? To break through 100,000 feet. Using the zoom climb technique, Jordan rocketed to 103,395 feet, or 31,513 meters, becoming the first aircraft to take off under its own power and cross both the 30,000 meter and the 100,000 foot marks in one flight. And this wasn't a marginal win. To claim the record, he had to beat the previous mark by at least 3%, which he did convincingly over a Navy attempt at the record. Just days earlier, on the 6th of December 1959, Navy Commander Lawrence Flint Jr. had zoom climbed his YF-4H-1 Phantom II over Edwards AFB. He accelerated to Mach 2.5 at approximately 47,000 feet and then pulled into a 45-degree climb, shutting down both engines near 90,000 feet also to prevent overheating, and he sailed up to a peak altitude of 98,557 feet on momentum alone before restarting his engines and returning safely. Jordan's climb followed the same profile. He accelerated up to Mach 2.36 at around 39,600 feet, then pulled up at approximately 3 Gs on a 49-degree climb. At around 81,700 feet, he shut down the J-79 engine and coasted the rest of the way, topping out at 103,395.5 feet, the official measurement. He restarted the engine on the way down and landed safely. This mission earned Jordan the 1959 Harmon Trophy. Now here's a record that few may know about. On May 11, 1964, Jacqueline Jackie Cochran, 58 years old, climbed into the cockpit of an F-104G at Edwards. She was no stranger to speed. Back in 1953, she'd become the first woman to break the sound barrier in a Canadair F-86 Sabre. This time, she was aiming to go faster. Flying a straight 25-kilometer course, Cochran pushed the Starfighter to Mach 2.16, recording an average speed of 1,429 miles per hour. It made her the first woman to fly faster than twice the speed of sound. Oh, and that day also happened to be her birthday. But she wasn't finished. A month later, on June the 1st, flying the same aircraft, she set a new speed record over a 100-kilometer closed circuit, this time averaging over 1,300 miles an hour. 2 days later, wrapped up the campaign with a 500-kilometer circuit at over 1,100 miles an hour, breaking a long-standing record from more than a decade earlier. In October 1961, the US Air Force Test Pilot School at Edwards Air Force Base was renamed the Aerospace Research Pilot School to reflect a new focus, preparing pilots for manned spaceflight. It was clear early on that if pilots were going to space, they needed more than just theory. They needed real, hands-on training in a vehicle that could simulate the conditions of spaceflight. But there was a problem. Flying in something like the X-15 was far too expensive to do routinely. The solution? Modify an existing, proven airframe to simulate the space environment. That idea became the NF-104A. The concept was to modify the Lockheed F-104 Starfighter by adding rocket propulsion and a reaction control system, creating a high-altitude aerospace trainer. In November 1961, Lockheed received a $5 million contract to modify 3 existing F-104As. The N in NF-104A stood for non-standard. Interestingly, Northrop had proposed a similar idea using a modified T-38, the ST-38, as early as 1958 and again in 1963, but the Air Force never pursued it. Transforming the F-104A into the NF-104A necessitated significant modifications. Along with the J-79 GE-3B engine, which featured longer double-shock intake cones, it also had a new rocket engine, the Rocketdyne LR-121NA-1, installed in an extended tail section at the base of the fin, using hydrogen peroxide as the oxidizer, and it produced 6,000 pounds of additional thrust. The Reaction Control System thrusters, or RCS, were arranged in pairs and were added to the top, bottom and sides of the nose for pitch in your control. The wingspan had also been increased by 1.2 meters, with twin reaction thrusters on each tip for high-altitude roll control. The dorsal spine housed the plumbing for the new systems, and the engine air inlets were modified for better airflow control at high altitudes. Internal tanks were also added to store the H2O2, and the pilot controls were also reworked to include all the switches needed for the reaction control systems. Pilots wore full pressure suits, the David Clark AP-22S2 for those interested, to survive the near-space environment. The mission profile for a Zoom flight was, to put it mildly, intense. A typical mission began from Edwards AFB with full afterburner at takeoff, which was described as being fired from a gun, accelerating to around 400 knots, and then continued climbing with military power at about 450 knots. As the pilot reached 35,000 feet, he would turn back towards the base. Once past Mach 1.8, the rocket took over and the aircraft climbed steeply at about 70 degrees until the peroxide was exhausted, usually near the apex of the zoom. By the time the aircraft reached 63,000 feet, the jet throttle was set to idle, and by 80,000 feet it was fully off. At the top of the climb, anywhere from 90 to 118,000 feet, the pilot had to maintain control using the RCS. At around 70,000 feet during descent, the pilot attempted to restart the engine. Re-entry and recovery typically occurred between 55,000 and 40,000 feet, while most flights ended with powered landings. On rare occasions, the pilot had to glide back for a dead stick landing. The entire flight lasted around 30 minutes. 3 aircraft were selected for modification: serial numbers 560756, 560760 and 560762, all of them former test aircraft at Edwards. They were delivered to Lockheed in late 1962, and the first F-104A flew in July 1963, piloted by Jack Woodman out of Palmdale, California. The next 2 followed in August and September. Woodman and Major Robert Smith split the initial flight test duties, with Smith reaching 118,860 feet on October 22, 1963. The next day, Woodman came close with an 18,400 foot flight. But the flights weren't always smooth. Both Smith and Woodman experienced departure from controlled flight at zoom apex, but managed to recover. It wasn't long before Aerospace Research Pilot School Commandant Colonel Chuck Yeager wanted to try his hand. At the time, the Soviets held the world altitude record at 113,892 feet, achieved in a modified MiG-21 by Georgy Mosolov in 1961. Yeager proposed that the F-104A could take the record back for the US, and he was approved to make the attempt. Yeager's first zoom climb was on December 4, 1963, reaching 94,500 feet, and 2 days later he reached 110,500 feet. That same day, Smith flew to 120,800 feet, the highest altitude ever achieved by the F-104A. Unfortunately, it was never made official since the proper record verification instruments weren't on board. Yeager tried again on December 9th and made 2 attempts on December 10th, and that afternoon, disaster struck. On a zoom climb passing through 101,600 feet in the aircraft 560762, the nose pitched up to 50 degrees. On previous flights, Yeager had used the RCS to bring the nose down, but this time it wasn't enough. The aircraft lost aerodynamic control and entered a flat spin. He deployed the drag chute, which momentarily stabilized the aircraft and managed to restart the engine. But once the chute was jettisoned at 12,000 feet, the jet pitched up again and re-entered the spin. Yeager ejected at 8,000 feet but suffered severe facial and hand burns when his helmet cracked during the ejection, and the aircraft was destroyed. An investigation blamed pilot error, but it also imposed a new altitude restriction: no more than 108,000 feet going forward. That, combined with shifting priorities and a lack of institutional support, kept the F-104A grounded for the next several years. Only the occasional check flight occurred. The Aerospace Research Pilot School didn't resume zoom flight training until June 13, 1968, when Captain Michael Lowe flew a mission to 93,000 feet. Over the next 3.5 years, roughly 50 students flew zoom climbs in the F-104A, typically reaching altitudes around 106,000 feet. In June 1971, aircraft 560756 was permanently grounded after an in-flight explosion during a transonic run. The pilot, Captain Howard Whitey Thompson, landed safely, but the rocket and part of the rudder were missing. The final flight of the F-104A took place on December 20, 1971. Major Ralph Graham took 560760 to 100,200 feet. By then, it was clear that the Air Force wouldn't be sending anyone to space aboard its own spacecraft. The F-104A had served its purpose. Today, the last remaining F-104A sits on display in front of the US Air Force Test Pilot School at Edwards. However, in the end, the F-104 did make it to the edge of space. Well, sort of. In 1967, a mysterious flying object appeared over US airspace. Naturally, the military scrambled their best and boldest. USAF Captain John Christopher, callsign Blue J4, in his trusty F-104, was sent to intercept the UFO. As he approached the unidentified craft, he was caught in his graviton tractor beam. Unfortunately, the UFO's tractor beam wasn't designed for 1950s aerospace engineering, and the F-104 disintegrated almost immediately, scattering itself across southern Nebraska. Fortunately, Captain Christopher, serial number 4857932, was safely beamed aboard the spaceship and was later returned to Earth, perhaps marking the first unofficial joint mission between the US Air Force and United Federation of Planets. Space at last, just not the way Lockheed had envisaged. The F-104's time with the United States Air Force was short, spectacular, and at times downright frightening. Although it entered operational service in February 1958 with the 83rd Fighter Interceptor Squadron, the reality was that the Starfighter was not yet ready for frontline duty and still required numerous technical issues to be resolved. From the outset, the aircraft was temperamental. Lockheed's engineers were still wrestling with major problems: compressor stalls, unreliable fuel supply, and afterburner issues that could turn deadly in a split second. The J-79 GE-3A turbojet that powered the first Starfighter models had quite a few issues, one of them being its variable exhaust nozzle, which would sometimes open at the wrong moment, leading to an abrupt loss of thrust. The results were tragic. Just 2 years after the first prototypes took flight, 22 aircraft had already been lost and 8 test pilots were dead. GE was slow to react, so Lockheed took matters into its own hands, building a dedicated engine test facility to find fixes on its own. Meanwhile, the fleet was grounded. The engine wasn't just unreliable, it was integrated into the aircraft. The F-104 used bleed air from the engine, fed to its boundary layer control system, which helped reduce landing speed, so if the engine quit, so did the flap blowing system, and in an aircraft with the gliding characteristics of an anvil strapped to a manhole cover, as one pilot once joked, meant that suddenly the rate of descent with gear down and engine off was not a fun experience. In 1959, Lockheed began retrofitting the F-104s with the improved J-79 GE-3B and eventually the much more reliable J-79 GE-19. However, by then, confidence in the jet had already begun to erode. The F-104's intercept radius with only internal fuel was just a few hundred miles. For the Air Defense Command, whose mission was to catch high-flying Soviet bombers over North America, that range was too limited. Worse still, the A and B models couldn't carry both tip tanks and sidewinders, it was one or the other. The F-104C added a centerline pylon that could mount a twin sidewinder rack or a catamaran adapter, but the drag penalty was severe and the setup was rarely used. I have read that there was one particularly dangerous quirk with the F-104's wing tip tanks that had to do with how they were filled. Each tank had a forward and rear compartment, and if the refueler filled the rear but not the front, it created serious problems. That imbalance could trigger wing flutter, a kind of oscillation that once started didn't dampen out. It actually grew worse until the wing tore itself off. That's precisely what happened to one pilot flying a 2-seat B model out of Edwards with a cameraman in the back for some photo chase work. At around 400 knots, the tank began to flutter, the wing broke loose and the jet rolled violently before both occupants ejected. But the incident didn't end there. Edwards is mostly sunny and dry, but when it gets windy, it really gets windy, and that day it was apparently howling. The pilot hit the lake bed and got dragged for a solid 25 minutes, chewing through the toes of his boots, most of his flight suit, and some less replaceable parts. The cameraman watching this unfold from his chute decided to release himself from the parachute harness earlier to avoid the same fate. Unfortunately, he misjudged the drop and hit hard enough to break a leg. After that, wind limits at Edwards were taken a little more seriously, no flying in winds above 25 knots. The F-104 was never quite what the USAF needed. Designed to beat MiGs in the clear skies over Korea, it arrived too late, and by then the Air Force wanted long-range all-weather fighters. One of the big knocks against the F-104 as an interceptor was its lack of compatibility with SAGE. the semi-automatic ground environment. Think of SAGE as an early version of real-time battle networking, a system where radar stations across the US fed information into massive computers that could track enemy bombers and then direct interceptors straight to them. The problem? The F-104 wasn't built to plug into that system. It lacked the specialized radar and data link equipment needed to receive commands from SAGE. So while other aircraft like the F-102 and F-106 could be seamlessly guided towards targets, the Starfighter was flying blind by comparison. For a supersonic interceptor, being fast wasn't enough, it had to be connected. And the Starfighter, despite its raw performance, was basically an offline jet. And with no SAGE-compatible radar, the ADC dropped it by 1960, just 2 years after entering service. Still, the Starfighter wasn't finished. Tactical Air Command would continue to operate the F-104C and D variants into the mid-1970s, this time as a nuclear strike fighter. The F-104C was equipped with a ventral pylon for a single tactical nuclear weapon, a toss-bombing computer, and a loadout of tip and underwing tanks. With tanks on, it could technically strike a target 800 miles away and return, but the added drag impacted performance. At full load, the F-104's climb rate dropped from 36,000 to 23,000 feet per minute, and at speeds exceeding 675 miles per hour, the aircraft developed fish-tailed instability, particularly when external stores were still attached. In the late 1950s, nuclear capability wasn't just for bombers. It was a badge of honor. Everything from Air Force One to the Boy Scouts, including fighters, had to have nukes. So Lockheed experimented with test-fitting one F-104 with an MB-1 Genie nuclear air-to-air rocket mounted on a trapeze under the fuselage that was lowered far enough from the airframe so the rocket exhaust wouldn't melt the airframe. Ultimately, it was too complex and didn't fit the F-104's mission profile. The system was shelved, although NASA reused the trapeze years later to launch experimental rockets. Initially envisaged as a pure air superiority fighter, then quickly repositioned as a high-speed point defense interceptor, and then as a nuclear strike fighter, it can be said that throughout its short USAF career that the F-104 wore many hats. Two-seat variants, the F-104B and D, were used primarily for pilot conversion and training, with the 331st Fighter Interceptor Squadron serving as the dedicated training unit. While it never fulfilled its original mission, the F-104 did see active deployment in several global flashpoints. For example, in the Second Taiwan Strait Crisis of 1958, F-104s were deployed near mainland China as a deterrent. In terms of real-world operations, the Starfighter was deployed more often than many realize. In 1961, at the height of the Berlin crisis, 3 Air National Guard squadrons were the first to fly the F-104 over Germany. The aircraft were ferried to West Germany by C-124 transports and then reassembled on NATO airfields as a visible show of force, and where they remained until August 1962. During the Cuban Missile Crisis, Air National Guard units flying F-104As were rushed to Florida to guard against any potential Cuban or Soviet aircraft incursions. The Starfighter was again called up in 1965 during the Dominican Republic crisis, with units stationed in Puerto Rico. And then came Vietnam. In April 1965, 25 F-104Cs from the 436th Tactical Fighter Squadron arrived at Da Nang. Although the F-104C Starfighter did deploy to Vietnam, its role was far more limited than many assume. It arrived during the early stages of Operation Rolling Thunder, tasked primarily with MIGCAP, providing high-speed cover for strike packages headed into North Vietnam. But it quickly became clear that a Starfighter was not an ideal match for the unique demands of the air war over Southeast Asia. At first glance, the F-104C had some things going for it. It was compact, brutally fast, and equipped with the M61 Vulcan, a cannon that many Phantom pilots have gladly traded missiles for during close-range engagements. In air combat tests back home, like those from Project Feather Duster, the F-104 showed impressive kill ratios against aircraft standard in for the MiG-17, so much so that some later argued that the Air Force might have bet on the wrong horse by going all in on the F-4 Phantom. But the skies over Vietnam weren't controlled test environments. Nearly 90% of US fighter losses during Rolling Thunder came from ambushes, with MiGs attacking from the rear quarter position before US pilots could even respond. And in that kind of engagement, the F-104's advantages such as speed, climb rate and small visual size didn't matter as much as situational awareness, radar coverage and survivability. The Phantom, with its two-man crew, larger radar and greater endurance, was better equipped to manage these threats. The Starfighter's lack of electronic countermeasure capability was a severe liability, especially once the North Vietnamese SA-2 SAM threat ramped up in 1967. Unlike the Phantom, which could carry a jamming pod with relative ease, the Starfighter just wasn't wired for it. And even if it had been, hanging a pod under the fuselage would have come at a cost of sidewinders or fuel, sacrifices it couldn't afford. Once the Phantom started flying with electronic countermeasures and later gun pods, any gap that may have existed between itself and the Starfighter had been closed. The F-104 had been out-evolved. Operational availability was another problem. By the time Rolling Thunder had kicked off, the Air Force had only about 50 serviceable F-104Cs left. Many had already been lost to engine failures or training accidents, and the prospect of fielding them in large numbers simply wasn't practical. And then came the MiG-21. Once the North Vietnamese forces began fielding fish beds in 1966, any lingering illusions about the Starfighter's edge in dynamic performance disappeared. In real-world conditions, the MiG-21 could outturn the F-104 at nearly any speed or altitude. Whatever advantage the Starfighter had in acceleration or climb rate just wasn't enough to make a difference. It had neither the maneuverability of the Crusader or the missile punch and the crew coordination of the Phantom. So despite their speed, 8 aircraft were lost in combat, 2 to surface-to-air missiles and 6 to anti-aircraft artillery. Another 6 were lost to operational accidents, and a Chinese MiG-19 shot down a Starfighter, with its pilot being captured. By mid-1967, the remaining aircraft were withdrawn from the theatre, and frontline USAF operations not long after that. In all, the USAF flew the F-104 from 1958 to 1975, although some training birds remained in service until 1983, NASA kept theirs flying until 1994, using them as chase planes and research platforms, more on that a bit later on. But the operational record was sobering. Out of 296 USAF F-104s, 49 were lost in accidents by April 1961. Engine issues alone caused 40 serious incidents, 24 aircraft losses and 9 pilot deaths in less than 5 years. Add to that the short legs, ejection seat woes, lack of sophisticated avionics, sensitive handling, and the fact that engine failure on approach often meant the end of the road for most pilots, is no wonder the jet earned its grim nickname, the Widowmaker. The F-104 was conceived at a specific moment in aviation history, but by the time it was ready, the world and the war it was built to fight had moved on. Lockheed might have parked it in museums and chalked it up to experience. But then again, as history shows, there were other forces out there with different needs, different goals, and who can resist a nice, fat envelope full of cash? After World War II, Germany's military was dismantled under Allied occupation. The Luftwaffe, once feared across Europe, ceased to exist. For nearly a decade, Germany had no air force, no aircraft industry, and no independent military structure. In 1950, the West German government formed a secret civilian office called Amt Blank, named after its head Theodor Blank. Officially, it was the Office for Special Affairs, but its real job was preparing the groundwork for a new German military without technically violating post-war restrictions. It worked behind the scenes to develop plans for manpower, command structures, equipment needs, and cooperation with NATO. The plan envisioned a modern NATO integrated military force comprising approximately 12 army divisions, as well as supporting air and naval forces. It also emphasized democratic control over the military, in sharp contrast to the Wehrmacht era. As Cold War tensions escalated, NATO viewed the rearmed West Germany not as a threat, but as a necessity. The Soviet Union loomed to the east, and the alliance needed more manpower and capability to counterbalance Warsaw Pact forces. The result was the formation of the Bundeswehr, Germany's armed forces, in 1955, West Germany's new military, and with it the rebirth of the Luftwaffe. At the time, NATO's Mutual Weapons Development Program was offering financial and logistical support for member nations adopting US standardized weapons systems. Lockheed saw an opportunity. So did Franz Josef Strauss, West Germany's defense minister. One of the early challenges was finding enough qualified people. Initially, pilot training was conducted under the guidance of the United States Air Force at Fürstenfeldbruck, a site that already hosted a NATO flying school. Early batches of pilots, many of whom were World War II veterans with experience in aircraft like the Bf-109 and FW-190s, underwent initial flying training on Piper L-18s at Landsberg. They then transitioned to Lockheed T-33s at Fürstenfeldbruck. Some German staff officers had already received some flying training in the USA and Britain. In the late 1950s, West Germany's Defense Committee actively evaluated nearly 24 advanced fighter designs from France, the United Kingdom, and of course the United States. The goal was to replace their aging fleet of Republic F-84 Thunderstreaks, North American F-86 Sabres, and Republic RF-84 Thunderflashes, which were becoming obsolete, with a single aircraft that could perform multiple roles: reconnaissance, tactical fighter bomber, nuclear delivery aircraft, and interceptor. Lockheed, well aware of the influence a German purchase would have, launched a focused and aggressive lobbying campaign. The Luftwaffe evaluated multiple aircraft, including the English Electric Lightning, the Grumman F-11 Super Tiger, French Dassault Mirage 3, the Saab J-35 Draken, the Convair F-102 Delta Dagger, the F-106 Delta Dart, Republic F-105 Thunder Chief, and the Vought F-8U Crusader, with the shortlist being whittled down to the Grumman F-11 Super Tiger, which was dropped as it didn't match the performance of the F-104 and the Mirage 3, which was a superior dogfighter, but that was also sidelined. On March 18, 1959, West German Defense Minister Franz Josef Strauss announced that the Luftwaffe would adopt the Lockheed F-104 Starfighter. A decision sets off what became known as the Sale of the Century, an extensive multinational procurement program that would see the Starfighter adopted not only by West Germany, but also by other NATO allies, including the Netherlands, Belgium, Denmark, and Italy. For West Germany, the F-104 program served dual purposes: rearmament under NATO guidelines and a revitalization of its aerospace industry. The government's choice to adopt the US airframe but to manufacture it under license in Germany ensured that the Luftwaffe would modernize. At the same time, German firms regained lost capabilities in aircraft design, system integration, and high-speed aerodynamics. Messerschmitt, Heinkel, Dornier, Siebel, and other firms contributed to airframe production, while Telefunken, Siemens, and AEG were involved in avionics and electronics. The F-104 program effectively jump-started the rebirth of the German aviation sector under NATO supervision. This decision dealt a massive blow to British aerospace ambitions. The United Kingdom had been promoting several aircraft, although that statement could be questioned. These included the English Electric Lightning, the Blackburn Buccaneer, and the still developing Sanders Roe SR-177 as alternatives to the Starfighter. All were technically capable, and in specific roles they were superior. The English Electric Lightning, a Mark II cable interceptor, was just about to enter RAF service and offered exceptional performance at high altitude. However, it lacked the multi-role flexibility the Luftwaffe required. It was designed primarily as a high-speed, high-level point defense fighter with limited range and payload and without ground attack capabilities. The Luftwaffe under NATO pressure needed a single platform capable of nuclear strike, reconnaissance and interception. The Lightning was thus eliminated from consideration despite its raw performance. The Marineflieger hotly favoured the Blackburn Buccaneer and was precisely what NATO needed at the time. This two-seat, twin-engined aircraft was designed as a rugged, fast, low-level strike aircraft and was miles ahead of the F-104 in terms of mission suitability. It offered excellent range, payload and stability at low altitude and was seen as ideal for anti-shipping operations in the Baltic. However, it was not yet in operational service in 1959 and its future was tied to the uncertain budgets of the Royal Navy. Also, politically, the Buccaneer lacked US backing, and concerns arose about standardizing a British design within NATO's predominantly US-led logistics and supply infrastructure. I also want to vent here. Had the British government pushed a little harder, they might have been able to secure sales for the Buck. There is a story about lost brochures. One persistent rumour is that the British sales brochures and technical documents for the Buccaneer sat unopened or were delayed in the British Embassy in Bonn, then West Germany's capital. Some versions say it was stuck in a diplomatic bag or forgotten in a filing cabinet. As a result, the German Defense Ministry never saw the proper sales pitch in time, while the Americans were aggressively lobbying with flashy materials, technical teams, and financial incentives. In any event, the Marineflieger's preference was overruled and thus the two Navy wings would also receive the F-104. Perhaps the greatest casualty of the F-104 decision was the Sanders Roe SR-177, a mixed propulsion interceptor intended to replace Germany's aging F-84s. Originally expected to be a joint Anglo-German project, the SR-177 was designed to meet NATO air defense requirements and featured both a turbojet and a rocket engine for rapid climb and interception. It showed great promise, but internal delays, mixed messaging from the UK government, and wavering German support led to its being dropped from consideration. When Germany selected the F-104, the SR-177 was effectively dead. However, the procurement was never just about technical performance. It was deeply tied to NATO politics, US influence in Western Europe, and the strategic objective of rebuilding German industrial capacity. However, in 1976, a US Senate investigation led by Senator Frank Church uncovered extensive bribery by Lockheed in securing foreign sales. West Germany was among the nations implicated. The investigation found that Lockheed had paid $22 million in bribes globally, including an alleged $10 million to German officials to secure the F-104 contract. Franz Joseph Strauss, though never formally charged, was a central figure of suspicion. In 1971, Germany's Auditor General criticized him for providing incomplete and misleading information to the Bundestag. When the scandal broke, critical files vanished from the Ministry of Defense, and the entire episode stained both Lockheed and the F-104 program in German public memory. Lockheed ultimately agreed to pay 3 million Deutschmarks at about $1.2 million in compensation to the families of 32 Luftwaffe pilots killed in accidents. If you want to read a cracking book about the whole Lockheed bribery episode, then I recommend The Grease Machine by David Bolton. However, the damaged reputation, public trust, and the Starfighters' legacy was already done, casting a retrospective shadow of what had once been hailed as a landmark NATO defense agreement. It's hard not to have a conversation about the F-104 without the subject of bribes being raised. For the Luftwaffe, the F-104, which was designated as the F-104G with G for Germany, was, as mentioned earlier, intended as a one-size-fits-all solution to replace the aging fleet of F-84s, F-86s, and RF-84 reconnaissance aircraft. The Marineflieger would phase out its Hawker Seahawks, despite the internal preference for the British Buccaneer for the F-104G. The new F-104G was significantly revised from the original A and C models, having reinforced airframes to handle a broader range of operational roles. It was also fitted with the J79GE11A engine, which could produce 10,000 pounds of thrust and 15,800 pounds of thrust with afterburner. This gave the G a maximum speed of 1,328 miles per hour and a combat radius of 420 miles, but with wingtip and drop tanks a ferry range of 1,630 miles, and a respectable service ceiling of 50,000 feet, but the English Electric F6 could hit 60,000 feet and the MiG-21 57,000 feet. The G also got larger control surfaces, most notably a powered rudder and an enlarged tail to improve handling. Combat maneuvering flaps are also added to address the aircraft's limited turning performance, and its avionics package was overhauled to support all-weather and multi-role capabilities. Central to this upgrade was the inclusion of the Autonetics F-15A NASAR radar system, which enabled both air-to-air and air-to-ground modes. Supporting systems included an autopilot, inertial navigation, and a bombing computer, all integrated into a modular electronics bay beneath the forward fuselage. Initial production began in the United States, but most F-104Gs destined for the Luftwaffe and the Marineflieger were built under license in Europe. Messerschmitt led German production, marking the country's first large-scale aircraft manufacturing effort since World War II. At its peak, the program employed around 100,000 people across Europe. West Germany ultimately acquired 916 Starfighters of various types, making it the largest operator of the aircraft in the world and would become the backbone of the West German Tactical Air Force. 5 Jagdbombergeschwader of the fighter bomber wings, including Jabo G-31 Bulker and Jago G-33, were equipped with the F-104Gs for nuclear strike operations. Despite being a non-nuclear state under the terms of the Non-Proliferation Treaty, West Germany's F-104s were assigned a dual-capable role under NATO, equipped with the US-supplied B-43 nuclear bomb. These units maintained high alert status and were trained to fly low-altitude penetration missions into Warsaw Pact territory should the Cold War ever go hot. Air defense roles were filled by JG-71 Richterhofen and JG-74 Mulders. 2 reconnaissance units operated the F-104G in a tactical photo intelligence role. Meanwhile, Marinefliegergeschwader 1 and 2 operated the type in the anti-shipping role from 1963 onward, transitioning to the MBB AS-34 Cormorant missiles in the late 1970s to extend their standoff capability. Training was carried out on the 2-seat TF-104G, a dedicated variant without combat systems like the M61 Vulcan. These aircraft focused heavily on low-level navigation and radar operation, preparing pilots for the demanding missions assigned to both Luftwaffe and Marineflieger units. When the Luftwaffe was reformed in the 1950s, it faced an immense task: building a credible modern air arm from scratch while navigating the political and technical challenges of the Cold War. Many men tapped to lead this effort were veterans from a very different era, fighter pilots with impressive wartime records who were now charged with bringing Germany into the supersonic age. Among them were some real heavyweights: Günter Rahl, Walter Koprinski, Johannes Steinhoff, and Erich Hartmann. All had cut their teeth flying piston-engine fighters over the skies of Europe, and now they found themselves climbing into the cockpit of one of the most advanced aircraft the West could offer, the Lockheed F-104 Starfighter. Rahl was among the first group of Luftwaffe pilots trained on the F-104 in early 1960. Krupinski had already flown the type during early evaluations and went on to command the Luftwaffe's first operational Starfighter wing. Steinhoff, a seasoned tactician and deeply respected commander, took on broader leadership responsibilities, eventually becoming inspector of the Luftwaffe. Even Erich Hartmann, the highest scoring ace in history, was given command of the newly reactive JG-71 Richterhofen. But while these men brought with them extraordinary flying credentials, it soon became clear that the jet age, and primarily the F-104, demanded an entirely different kind of preparation. Initial training for German F-104 pilots began in the United States at Lockheed's Palmdale facility and at Luke Air Force Base in Arizona. Conditions there were near ideal: vast open skies, warm weather and ample airspace. But when these pilots returned to Germany, they faced dramatically different circumstances. The narrow confines of Central European airspace, coupled with frequent low cloud cover and complex terrain, presented a far more demanding environment. The transition from the clear blue skies of Arizona to the murkier, less forgiving conditions of Northern Europe proved harsh. Out of the 916 Starfighters acquired by West Germany, 292 were eventually lost in crashes. At least 115 pilots died, though some records suggest the true figure may be slightly higher. In total, nearly 1/3 of the German F-104 fleet was lost in accidents. Official sources tried to contextualize the loss rate, noting that it translated to roughly 1 crash per 6,600 flying hours, a figure within international norms. But those numbers offered little comfort to a German public that had come to associate the Starfighter with tragedy. And it wasn't long before the aircraft earned its dark nicknames such as the Widowmaker and the Flying Coffin. So, what went wrong? The answer is complex. And according to official reports, it is rooted in several interconnected causes. To begin with, the F-104 was never designed to perform the task Germany requested of it. Its original purpose was to be a high-speed, hit-and-run, pure air superiority fighter capable of brief, decisive engagements. In Germany, however, it was deployed across a range of roles, including low-level strike, reconnaissance, all-weather interception, and even nuclear delivery. Flying at treetop height in poor visibility placed enormous demands on pilots, especially those with limited hours in the type. And in these conditions, the margin for error was narrowed dramatically. It was not built for the kind of multi-role low-altitude operations Germany demanded of it, and the consequences were predictable. Training infrastructure was also an issue. The Luftwaffe was still growing into its post-war identity, and both pilot training and ground support struggled to keep pace with the sophisticated technology of the F-104. In its early years, maintenance capacity was limited, hangar space was lacking, and many aircraft spent long periods exposed to the elements. Meanwhile, young pilots were being transitioned directly into Starfighters from slower, less complex jets. By contrast, pilots from countries like the Netherlands, the US, or Belgium often had hundreds more flight hours before strapping into a Starfighter. Then there was the General Electric J79 engine. Although powerful and reliable in many conditions, it was unforgiving when mishandled and suffered from a series of recurring issues, including compressor stalls, flameouts, fuel control anomalies, and nozzle failures, among others. Meanwhile, the aircraft's high wing loading required pilots to approach the runway at very high speeds, often exceeding 180 knots. Landings became exercises in precision, with pilots having to maintain power all the way down to prevent loss or lift. The slightest misjudgment could and often did prove fatal. Aerodynamically, the Starfighter also posed unique challenges. Its susceptibility to pitch up at high angles of attack, where the aircraft would abruptly stall without warning. Lockheed attempted to fix this with the stick shaker and stick kicker systems, however these systems could potentially malfunction. By 1966, the rising number of crashes and the public outcry led to Johannes Steinhoff ordering the entire fleet grounded. He tried to convince politicians that the Luftwaffe needed more funds to build hangars for its hundreds of F-104s that had been sitting out in the elements, affecting their avionics, along with more money to improve training for all personnel. It's important to note, however, that Germany was not alone in facing losses. The USAF lost nearly 50 of its 296 F-104s by 1961. Canada's attrition rate with its CF-104 was proportionally even higher, losing 110 of 238 aircraft, though Canadian pilots also accumulated a lot more hours per airframe, and we have to take into account the demanding low-level nuclear strike role and the long flight hours required for this mission. However, other operators had much better records. Spain operated its F-104s for 7 years and lost no Starfighters in 17,000 hours of flying, and Norway lost just 6 in 56,000 hours of flying, figures reflecting both limited mission profiles and more favourable operating conditions. This suggests that the Starfighter, while demanding and unforgiving, was not inherently doomed. Instead, its safety record often reflected the environment in which it was flown and the level of preparation given to those flying it. To their credit, the Luftwaffe leadership eventually faced these problems head-on. Steinhoff's training reforms and equipment upgrades began to reduce losses, operational doctrine was adjusted, and confidence in the aircraft, while never fully restored, started to stabilize. Despite the risks, many Luftwaffe pilots held the aircraft in high regard. When flown within its limits and well maintained, the Starfighter was described by many pilots who flew it as a source of reverence. It was an unforgiving aircraft, one recalled, but if you treated it right, it gave you everything. By the early 1960s, with Cold War tensions running dangerously high and nuclear retaliation strategy at the forefront of NATO doctrine, military planners were grappling with a chilling reality. What if a first strike rendered air bases unusable? In a scenario where runways were cratered or overrun, how could NATO still guarantee a retaliatory strike? Out of this question emerged some of the most extreme, imaginative, and sometimes alarming experiments in Cold War aviation. Among them were ZEL and SATS, two highly unconventional programs that involved the F-104 Starfighter. ZEL stood for Zero Length Launch, a concept as audacious as the name suggests. The idea was brutally simple. Rather than relying on vulnerable runways, a Starfighter could be launched vertically, more or less, from a static position using a powerful rocket booster. This wasn't theory, it was actually tested, developed and even flown first by the US Air Force using earlier jets such as the F-86 and F-100 and later by the Luftwaffe with its frontline fighter, the F-104G. Germany formally entered the ZEL program in 1963 and after preliminary manned launches in the US, the trials were moved to an airbase in Bavaria in 1966. A solid fuel rocket delivering 24,000 pounds of thrust would accelerate the aircraft into the sky within seconds. The booster, once spent, would be jettisoned and the Starfighter would then continue on its mission as usual. Before every launch, the pilot would power up the J-79 engine, engage full afterburner, and then with hands on the controls, although ironically little actual control in that instant, the rocket would be ignited and away they went. Some pilots even debated whether they should just keep their hands on the ejection seat handle just in case something went wrong. And in truth, while the launches were successful, the risks were considerable. Psychologically, it was a test of nerves more than skill. As one pilot remarked, it felt like sitting on a gas can and lighting a match. Official records show that by mid-1966, 7 successful ZEL launches were completed in Germany. Each one cost around 115,000 Deutschmarks, a considerable sum at the time, but the writing was on the wall. The idea of launching nuclear-armed fighters from the roadside became increasingly implausible and the program was quietly discontinued. At around the same time, another experiment was underway, one that addressed a similar concern but from a different angle. This one was called SATS, or Short Field for Tactical Support, and was a joint project with the US Marine Corps aimed at proving that fast jets like the F-104 could operate from improvised carrier-style airstrips on land. Think of this as a mobile airbase, short, portable runways with catapult-assisted launches and arrested landings. Germany modified 3 Starfighters with reinforced fuselages and tailhooks to participate in this program. The concept was bold, but the execution was unforgiving. The Starfighters were never designed to land like carrier jets, and while the reinforced hook allowed for arrested landings, the margin for error was razor thin. The aircraft had to approach at high speed and catch the arresting wire without flaring. The pilots had to descend with precision, often rotating the nose downward at the last moment to ensure the hook hit first. Simultaneously, they had to be ready to slam the throttle wide open just in case they missed the wire. According to official Luftwaffe accounts, the entire process was described as a controlled crash. There was no room here for mistakes. The Starfighter's short wings designed for speed didn't generate much lift at low speeds and the approach became turbulent and complex to manage. Not every landing went according to plan. In one test, the Starfighter overshot the arresting gear, but a backup net saved both the pilot and the machine from disaster. It was a close call that underscored just how unsuited the Starfighter truly was for this kind of mission, and yet the tests continued. The SAT's program also included catapult launches, whereby a sledge would hurl the aircraft to 200 knots in just 8 seconds. In this setup, the Starfighter's landing gear was locked onto the sledge, which was accelerated down a 700-foot track, and although the idea worked technically, Germany found little operational value, and by 1966 the Bundeswehr deemed the concept impractical and terminated the whole program. In hindsight, both Zell and SATs were expressions of Cold War anxiety born from very real fears of a Soviet first strike and the perceived need to keep NATO's nuclear deterrent mobile and unpredictable. But they also highlighted the F-104's limitations in anything but conventional roles. Official Luftwaffe documents from the period reveal that these experimental operations, although valuable from an engineering standpoint, placed enormous physical and psychological strain on the pilots and achieved little in resolving the fundamental issues the Starfighter already faced, particularly during what would soon be known as the Starfighter crisis. That crisis, defined by a shockingly high attrition rate among German F-104 pilots, was already unfolding, and while experiments like Zell and SATs were driven by strategic necessity, they also revealed how far the Luftwaffe was willing to push its aircraft, its airmen, in the name of preparedness. However, you can't fault them for their innovations, and if you want to read about a pretty interesting one, look up the F-104 CCV, where the Germans took a Starfighter and developed it into an early fly-by-wire platform. The Luftwaffe's F-104 Starfighters had a relatively long service life after entering service in the early 1960s, but by the late 1970s their frontline role had begun to diminish with the introduction of aircraft such as the F-4 Phantom II and later on the more advanced Tornado. The Luftwaffe began phasing out the F-104 from operational units in the early 1980s, and the type was officially retired from combat service in 1987. However, a small number of airframes remained in use for testing and training purposes into the early 1990s. Now, let's bring on the Italians. I must thank l'Aeronautica Militare Italiana for my fascination with the F-104 and aviation in general. When I was a kid, about 8 or 9, while flipping for a magazine, I came across a photo of a Starfighter in Italian livery. And she, well, looked just right. Being young and a bit naive, I figured this must be an Italian design. It had that aggressive style and sharpness that made it feel like a product of Italian engineering flair, and I was hooked. Only later, as I read the article, did I learn the truth. It was a Lockheed design, pure Americana. Hats off to you American lads, you built a real beauty. But the Italians made it their own. And that's where our story begins. So, as they say in Italy, andiamo. La Aeronautica Militare Italiana, or simply AMI, would become the aircraft's most enduring operator, flying various Starfighter models for an extraordinary 42 years. That longevity speaks not just to the aircraft's adaptability, but to the scale of Italy's commitment. When Italy signed a license production agreement on March 2, 1961, it threw nearly its entire post-war aviation industry behind the Starfighter program. But of course, that decision wasn't made in isolation. When West Germany took the lead in adopting the F-104 as part of NATO's strategic posture against the Soviet bloc, it was only natural for other European countries, including Italy, to follow suit. Italy received 124 F-104Gs built under license by Fiat, with additional aircraft sourced from Germany and the Netherlands. The first Fiat-built F-104G flew on the 9th of June 1962 and began replacing the F-86s and F-84s and RF-84 in AMI service, quickly earning the nickname Spillone or Hatpin. Reconnaissance duties fell to the RF-104G, which was fitted with the trimetragon camera arrangement. However, later it would be modified to carry the Dutch Orpheus reconnaissance pod, while training was carried out in the TF-104G 2C trainers. Initially, 12 of these came from Lockheed and another 12 were built locally. Later, more were acquired second-hand from Germany to replace those lost to attrition. But the heart of the Italian Starfighter is the F-104S, the S standing for Sparrow. This wasn't just simply another variant. It was a significant evolution explicitly designed for Italy and later Turkey. Lockheed received an Italian contract to modify two Fiat-built F-104G Starfighters as prototypes, designated model CL901s. These were to become the first 104S Starfighters. This was to be an advanced all-purpose aircraft with improved capability both as an interceptor with radar and as a fighter bomber with a 20mm Vulcan cannon that could haul up to 7,500 pounds of bombs, napalm tanks or rocket pods. And under the skin, it had an uprated J79GE19 engine producing 11,870 pounds of dry thrust and 17,900 pounds of afterburner, along with a 13% improvement in cruise fuel efficiency. With a slight relocation and increase in size of the air intakes, improved airflow, the F-104S could now push past Mach 2.2, stretching the Starfighter's already blistering speed even further, typically Italian. But it wasn't just a faster jet. The new engine also meant that the S could climb faster, with a time to climb of 34,777 feet in just 80 seconds, which was 10 seconds faster than the F-104G. Perhaps one of the finest moments for the F-104S in Italian service came when Air Italia test pilot Napoleone Bragagnolo rocketed the 400 miles from Torino to Rome in just 19 minutes and 30 seconds, still carrying 340 gallons of fuel in his wingtip tanks when he touched down. And just to give you an idea how quick that was, by train that would have taken over 4 hours and by car about 7 hours to drive. Apart from having a more powerful engine than the Germans, the Italian Starfighter could carry a greater payload. Along with the 9 external store stations, almost double the capacity of earlier variants, it was finally wired for radar-guided missiles, namely the AIM-7 Sparrow II and/or 2 AIM-9 Sidewinder missiles. To support that, the aircraft came with a new Fabbrica Italiana Apparecchiature Radioelettriche, or simply FIAR built radar, derived from the NASAR system capable of a continuous wave target illumination. For navigation, the Lytton INS gave the Starfighter true all-weather capability. While some versions focused on the air-to-air mission, others were designated for ground attack. The first Lockheed modified F-104S was flown in December 1966, and Fiat subsequently produced 246 of these variants for the Italian and Turkish air forces, with deliveries spanning from December 1968 to March 1979. That decision didn't happen in a vacuum. In the late 1960s, the AMI had plenty of other options on the table. For instance, they had the McDonnell Douglas F-4 Phantom, which was a proven multi-role aircraft. The Mirage 3 was another. It was a fast, agile, and known for its dogfighting abilities. They even considered the lightweight F-5. But none of these were as fast as the F-4S, and none of them came with the same industrial opportunities. That part mattered. Italy's aerospace industry had been essentially tied to the Starfighter since the early 1960s. The licensed production of the F-104G in 1961 had consumed almost the entire capacity of the domestic aviation sector. By staying with the F-104, by investing in the S model and building it locally through Fiat and later Air Italia, the AMI kept the momentum alive. So even though it was faster and cheaper than the F4 but not as agile as the Mirage, the F4S was chosen not just for what it could do or not do in the sky, but for what it meant on the ground. Jobs for Italians. And of course that wasn't the whole story. When the Lockheed bribery scandal eventually came to light, it cast a long shadow over Italy's defense decisions. But was it any surprise? Italy has never been known for its political purity. One of the most high-profile casualties of this saga was Luigi Gui, who had served as defense minister during the early 1970s and who had also agreed to purchase 14 C-130 Hercules transport aircraft from Lockheed in a deal worth $60 million. The deal wasn't without controversy. Some critics at the time argued that locally produced aircraft such as the G222 were just as capable and would have been less expensive. But the deal went through anyway. Years later, when the US Senate's Church Committee began peeling back the layers of Lockheed's secret payments, it emerged that $2.2 million had been funneled to Italian agents, with over 85% of that reportedly passed to government officials. According to Lockheed's own internal documents, one company consultant was told in no uncertain terms by an Italian senator that unless money changed hands, there would be no sale. When the scandal finally broke in 1976, Gui, then serving as Interior Minister, stepped down from his new cabinet position formed by Prime Minister Aldo Moro. Officially he did so hoping to clear his name, but the damage was done, and suddenly the decision to keep the F-104 looked tainted. But even among the cynics, there was a recognition that the aircraft itself wasn't without merit. By 1960 standards, it could still fly faster and higher than almost anything else in Western Europe. Pilot training for this new fleet began with help from Germany, where Italian pilots initially trained with the Luftwaffe after completing ground school in the Netherlands. Transition flights were conducted in the F-104 F2-seater and then later the TF-104G. A full conversion course included 7 flight stages, roughly 6.5 hours in total, which provided pilots with experience in supersonic flight, instrument procedures, formation flying, and a Mark II dash, with the program culminating in a solo flight. By early 1965, the AMI had stood up its own operational conversion unit, the 20 Gruppo a Grosseto, marking a new level of independence. From there, Italy began building its own Starfighter force. The F-104s took on multiple roles within the AMI: interceptor, fighter bomber, and tactical reconnaissance, and initially 4 Gruppi operated as mixed interceptor fighter bomber units, with 2 more assigned to reconnaissance. When the F-104S began to arrive in 1970, it strengthened and gradually replaced older models in the fleet. Units such as the 9 Gruppo a Grosseto and 18 Gruppo at Trapani Birgi and 21 Gruppo at Novara Cameri flew the Starfighter well into the 1980s. By 1986, Italy had the largest operational F-104 force in the world, comprising of 11 Gruppi. Starfighter pilots were on permanent quick reaction alert status with the ability to scramble within 15 minutes, and in reality many were trained for a 5-minute launch, and this just showed just how seriously the AMI treated its air defense mission. These weren't aircraft that loitered or patrolled lazily over borders. They were built to climb fast, strike hard, and get back down again in time for gelato and espresso. Accident rates, often the defining controversy in other nations, were comparatively restrained in Italy. From 1964 to 1993, 16 Italian pilots lost their lives in Starfighter crashes. While any loss is significant, these figures paled in comparison to Germany's 110 pilot fatalities or Canada's 37. The AMI did their best to maintain strict procedures and were continuously modifying training to reduce the risk. But as always, the Starfighter's biggest drawback was always going to be its endurance. Flying in afterburner drained fuel rapidly, forcing a very tight mission profile. Because remember, this was still an aircraft built around a rapid climb rate and top speed, rather than dogfighting agility or payload flexibility. One AMI pilot famously quipped that they performed aerobatics only after we have reached the assigned target and returned to base, because if we fall, we can fall on government property. The humour underscored a profound truth: the Starfighter demanded discipline, not flair. Italy maintained its fleet by continuing to update it with a series of upgrades, and starting in 1983, the F-104S was updated to the ASA standard, or the Aggiornamento Sistemi d'Arma, or Weapon System Update. This added a new R21G/H look-down shoot-down radar system designed to detect and track low-flying intruders. The weapon system also included Salinia Espiri 1A air-to-air missiles and modern ECM systems to see the aircraft remain in frontline use until at least another decade into the 1990s. Trials began in 1984, and by the end of the program, 206 aircraft had received the upgrades. A later round of updates in 1998 produced the ASA/M models. Although these weren't combat improvements but reliability upgrades, They added GPS, modern TAC and navigation, updated Lytton inertial systems, and improved cockpit displays, returning the aircraft to a pure interceptor role. Italy flew the F-104 longer than anyone else. The final Starfighters were retired in 2004, replaced by leased F-16s as the Eurofighter Typhoon prepared to take over. In those 4 decades, Italy not only operated the F-104 but also built it, upgraded it, and flew it with a confidence that few other countries ever matched. For better or worse, the Starfighter became part of Italy's aviation identity and pretty much doomed me and many others to a life of looking skyward. Many nations took on the Starfighter, whether for their own strategic, political or industrial reasons, with each country contributing their part to the Starfighter's complex history. Each of these countries we're about to cover could have made an entire episode on their own, possibly one day, so if you're watching from one of these places, please leave a comment and I'll see what I can do. Perhaps no country's decision to adopt the F-104 was more politically loaded than Canada's. In the late 1950s, Canada stood on the brink of aerospace independence with the revolutionary Avro Arrow. This delta-winged interceptor promised to be one of the most advanced fighters of its time, but in a move that still rankles, the Arrow was cancelled in 1959 and its replacement came not from Canadian drawing boards, but from California, the Lockheed F-104 Starfighter. The Canadian variant, known as the CF-104, replaced the aging Sabres and Canucks of the 1st Air Division. Canadair built 200 of them under license, with another 140 produced for NATO partners. Though the aircraft was initially optimized for nuclear strike and high-speed reconnaissance, its role evolved over time to include conventional ground attack. Canadian pilots were first trained in the US and then at Cold Lake, Alberta, where they developed a reputation for flying with surgical precision at high speeds and low altitudes. However, that precision came at a cost. Canada would suffer one of the highest attrition rates of any F-104 operator, losing nearly half of its fleet and 37 pilots over its service life. But I have to add here that these aircraft flew far more hours than their counterparts elsewhere. Introduced in 1963, Norwegian Starfighters arrived at Bodø via ship and were famously towed through the town to their new home on the airbase. Initially, Norway flew the Starfighter in a strike role, but by the late 1960s, it had transitioned to a dedicated air defense mission intercepting Soviet intrusions in Arctic airspace. Norwegian pilots, handpicked for their experience, benefited from extensive training and a well-structured transition program, resulting in a remarkably low loss rate. Over 56,000 flight hours, Norway lost only 6 Starfighters, a safety record that still stands as one of the best in the type's history. To the south, Spain operated the F-104 for only a short time, but with an equally enviable safety record. Spain got 21 aircraft through the US Military Assistance Program in 1965, and they based their Starfighter squadron at Torrejon Air Base. Although its tenure lasted just 7 years, the fleet was flown without a single recorded accident, further underscoring that in the right hands and environment, the F-104 could be tamed. The F-104 Starfighter held a prominent, if sometimes controversial, place in the Belgian Air Force for over 2 decades. Belgium acquired a total of 113 Starfighters consisting of 101 F-104Gs and 12 TF-104G 2C trainers. Most were built under license by Sabca, while the trainers were supplied directly by Lockheed. They entered service in 1963, and the F-104 replaced the CF-100 Canucks in interceptor roles and soon expanded into the strike attack mission across 2 wings, Beauvechain 349 and 350 squadrons for air defense, while Klein-Brogel's 23 and 31 squadrons handled the fighter bomber role. Belgian Starfighters were equipped for both missions to maximize their utility, with the electronics alone accounting for nearly 40% of the aircraft's cost. Pilot training was intensive. Initially, Belgian crews trained with the USAF and Luftwaffe in Germany, progressing through 7 phases that included high-speed supersonic runs and Mark II flight. But by 1966, Belgium had established its own training unit, called Flight TF, but due to the aircraft's reputation for needing skilled flyers at the controls, led to the recruitment of veteran non-commissioned officers, some with over 2,500 hours of jet time as frontline pilots. Remarkably, none of the 45 NCOs who flew the Starfighter were ever lost in accidents. Later, younger and less experienced pilots would be accepted, including some with as little as 300 total flying hours. Despite, or perhaps because of its performance, Belgium lost 41 Starfighters and 23 pilots, an attrition rate of roughly 37%. Many losses stem from engine flameouts, compressor stalls, early ejection seat limitations, and the infamous pitch-up phenomenon. Mid-air collisions, bird strikes, and even bizarre ground incidents like a raincoat being sucked into an intake. Among its more memorable roles, the F-104 flew with the Belgium aerobatic team, the Slivers, formed in 1969. Named after the jet's sleek profile and polished metal finish, the team flew 68 performances across Europe before being disbanded in 1975. Their legendary touch-roll-touch maneuver, where the aircraft took off, then straight into a roll followed by a landing, became infamous. But tragically, this pretty spectacular maneuver led to one fatal training accident before being banned. By the early 1980s, the Starfighter's time was nearing an end. Belgium began phasing it out in favour of the F-16 Fighting Falcon, with the final F-104s being retired in September 1983. Some found new lives abroad, 23 were sent to Taiwan and 18 went to Turkey, but for Belgium, the Starfighters era had come to a close. The F-104 Starfighter served the Royal Netherlands Air Force from early 1960s through to the mid-1980s. In total, the Netherlands received 138 Starfighters, a mix of F-104Gs, RF-104Gs reconnaissance models, and TF-104G 2C trainers. The path to acquisition was anything but straightforward. Initial hopes for full US funding through the Military Assistance Program fell short, and Lockheed's offer came with strings attached, including conditions tied to Italy's participation in the program. Eventually, a combination of purchased and map-funded aircraft brought the Dutch Starfighter force to strength. However, the Netherlands' selection of the Starfighter was later overshadowed by, of course, the Lockheed bribery scandal. The scandal centered on allegations that Lockheed had paid at least $1 million to Prince Bernhard, the husband of Queen Juliana, in exchange for influencing the Royal Netherlands Air Force decision to adopt the Starfighter. It's just the world we live in. Anyway. Most of these jets were produced under license through the ARGE Nord consortium, with Dutch firms like Fokker and Aviation playing leading roles. Fokker handled final assembly and flight testing at Schiphol Airport and also built key components for all European Starfighter programs. Aviation, on the other hand, crafted elements such as radomes, fuselage sections, and landing gear doors. The first Fokker assembled Starfighter took flight in November 1961. With operation deployment following soon after with 306 Squadron that operated a reconnaissance configured RF-104G and also served as the Starfighter's initial conversion unit. Over time, the F-104G equipped frontline squadrons in both the interceptor and fighter bomber roles, 322 and 323 squadrons taking up the air defense mission, while 311 and 312 squadrons handling the strike role. The reconnaissance aircraft were fitted with Dutch-built cameras and from 1974 carried the locally developed Orpheus pod, an advanced system that allowed for night and all-weather operations. Initially, pilot training posed a challenge due to a shortage of the trainer variants. Early Dutch pilots trained with the Luftwaffe in Germany, and candidates needed at least 1,000 hours of jet time before stepping into the Starfighter's cockpit. Despite its strengths, the Starfighter earned a mixed reputation in Dutch service due to its accident rate. Over 2 decades, 44 Dutch F-104s were lost in crashes with 19 pilots killed, an attrition rate of nearly 36%. Incidents ranged from mid-air collisions to engine failures and bird strikes. Still, many pilots loved the aircraft. By the early 1980s, the Starfighters' time with the Dutch Air Force was drawing to a close. The F-16 Fighting Falcon began replacing it squadron by squadron, and the final F-104 flight in Dutch service, a TF-104G, touched down on November 26, 1984. Several Dutch Starfighters went on to serve with other NATO allies. 53 were transferred to Turkey and 10 to Greece. Others were preserved, including the TF-104G D5805, now at display at the Dutch Air Force Museum. Perhaps the most unusual chapter in the Dutch F-104's career came during a domestic counter-terrorism operation. In a now infamous maneuver, on May 23, 1977, two Dutch F-104s performed a low supersonic flyover to disorientate a group of train hijackers. It was an unconventional use of a supersonic interceptor, but it seemed to do the trick. Denmark too entered the Starfighter fold by acquiring second-hand CF-104s and trainers modified to meet the F-104G and TF-104G standards. Their role mirrored that of other NATO air forces, strike and reconnaissance, though specific operational details are less documented. Still, Denmark's adoption of the Starfighter kind of reflects the broader pattern of Cold War air forces, choosing the F-104 for its availability, NATO compatibility, performance potential, even when it arrived second-hand. In Greece, the Hellenic Air Force operated the F-104 Starfighter from 1964 to 1993, having acquired 159 aircraft from various sources, including the US, Germany, Spain, the Netherlands, and Italy. Initial deliveries came under the US Military Assistance Program, followed by transfers of ex-Luftwaffe aircraft and additional European-built airframes. The aircraft served primarily with the 335 Mira Tiger and the 336 Mira Olympus squadrons, first at Tanagra Air Base and later relocating to Raxos. Greek pilots, known for their exceptional formation flying, often describe their love-hate relationship with the Starfighter. During its nearly 3-decade service, Greece lost 13 Starfighters with 16 pilots killed. Nevertheless, the Starfighter earned a respected place in Greek aviation history, logging over 224,000 flight hours before retirement. Turkey was one of the largest operators of the F-104 Starfighter outside of the US and Germany, flying over 400 aircraft between the 1960s and 1990s. Acquisitions came through a combination of map deliveries, NATO allied transfers, and direct purchases, including 40 Italian-built F-104S interceptors. The fleet included models from Canada, Norway, Belgium, Spain, Italy, and the Netherlands, though many were cannibalized for parts rather than flown. The Starfighter's long service in Turkey was marked by operational intensity and a relatively high attrition rate, with several recorded crashes, including fatal incidents as late as 1992. By 1995, all remaining F-104s had been replaced by the F-16. The Royal Jordanian Air Force received 36 F-104 Starfighters comprising of 29 F-104As and 4 F-104Bs, starting in the spring of 1967 under the US Military Assistance Program, with many of the aircraft previously operated by Taiwan. The jets were initially equipped for No. 9 Squadron at Prince Hassan Air Base, but were temporarily withdrawn to Turkey just days before the outbreak of the Six-Day War in June 1967. The US was hesitant to return them, but pressure from King Hussein, who threatened to turn to the Soviets for MiG-21s, led to their return. Later, refurbished F-104s were transferred to 25 Squadron, and some Pakistani Air Force pilots, veterans of the Starfighter, trained on them during the early 1970s when regional tensions were high. The Starfighter even played a role in Jordan's internal security when one aircraft flew a sortie during a failed coup attempt in November 1972. Operational losses were relatively low. Only one aircraft was lost in training, and another was successfully dead-sticked after an engine flameout. The aircraft were gradually phased out, first by the F-5 Tiger and ultimately replaced by the Mirage F-1 in the early 1980s. In Japan, the F-104 Starfighter was known as the Iku, meaning glory, and served with the Japan Air Self-Defense Force from 1966 until 1986, defending the country against every imaginable kaiju. Japan acquired 210 F-104J single-seater interceptors and 20 F-104DJ trainers, all based on the F-104G but tailored specifically for the air defense role, in line with Japan's strictly defensive military doctrine. These aircraft were produced under license by Mitsubishi Heavy Industries with power provided by a locally built J79 IHI-11A engine. The J was equipped with a simplified air-to-air only version of the NASAR radar and armed with a 20mm cannon and Sidewinder missiles. No ground attack capability was included, nor did they transform into giant sentient robots. The type entered service as the 201st Heiko Tai and was eventually operated by several squadrons across Japan, including the 2nd, the 5th, the 6th and 7th Air Wings. The Japanese Air Force pilots admired the Starfighter, calling it a true pilot's aircraft and comparing it to a mount fit for a Sky Samurai. Initially flown in a polished metal finish, later aircraft were painted light grey to reduce corrosion. While other nations struggled with the F-104's accident rate, Japan maintained a relatively safe operational record with around 15% attrition over 2 decades, including a few mid-air incidents. The F-104Js began to be replaced by the F-15 Eagle in the early 1980s, and the last were retired in 1986. Some aircraft were later used as target drones and others were transferred to Taiwan's Air Force. Taiwan operated one of the largest and most enduring Starfighter fleets, flying the F-104 for 38 years under the Aslihan program, which saw 281 aircraft including F-104As, Bs, Gs, RF variants and ex-Japanese F-104Js enter Republic of China Air Force service. Deliveries began in 1960 with the 3rd Tactical Fighter Wing receiving the first aircraft, but as diplomatic tensions limited access to new Western fighters in the late 1970s, Taiwan turned to NATO allies for surplus aircraft, acquiring jets from Germany, Belgium, Denmark, Japan and others to keep the fleet viable. The aircraft were widely distributed across interceptor, strike, reconnaissance and training squadrons. The Taiwanese Air Force scored at least one air-to-air kill in 1976 when F-104G downed the Chinese J-6 or MiG-19 with a missile. However, the long service life came with heavy attrition. Crashes claimed dozens of aircraft and pilots, including the commander of the Taiwanese Air Force in 1990. Despite its aging design, the Starfighter remained central to Taiwan's air defense until the 1990s, when it was gradually replaced by the indigenous FCK-1 Chingku and the Mirage 2005 fighters. The final retirement came in May 1998 after more than 380,000 flight hours. Each of these nations approached the F-104 in a different manner. Some embraced it, others simply adopted it as part of their NATO obligations. But in each case, the Starfighter left an unmistakable mark, whether in Canada's painful trade of innovation for alliance, in Norway's careful and competent use of a demanding aircraft, or Spain's brief yet effective deployments. The Starfighter's story didn't end with her military retirement. Long after most of its contemporaries had faded into museums or fallen into the hands of the scrap merchants, some lucky F-104s found a second life with NASA and later in private hands. Florida-based company Starfighters Inc. operates a fleet of these legendary aircraft for civilian demonstrations, flight research, and even conceptual suborbital launch operations. Starting with former Canadian CF-104s and later acquiring Italian-built F-104S models, they've turned the jet into a flying lab and a star attraction on the airshow circuit. The sight and sound of a Starfighter lighting its afterburner will still draw a crowd no matter what. In the end, her story defied easy categorization. It was only while researching this video that I truly understood that she was an aircraft of contradictions, elegant but unforgiving, futuristic yet flawed, a triumph of design and a cautionary tale in equal measure. And while her place in aviation history remains divisive, one truth is clear: few aircraft were ever asked to do so much by so many in so many different ways. The Starfighter wasn't for everyone. She didn't suffer fools. She was exacting and could be cruel to the careless, but those who flew her with skill and respect, she was unforgettable. As one veteran said, she demanded your full attention, but if you gave her that, she gave you everything back. I want to take a moment here to thank everybody that's helped me put this project together. everyone who allowed me to use their photographs and everyone who allowed me to use their videos for this particular project. Now, this one was a massive undertaking. And yeah, you can see after 2 hours of, I have pretty much covered as much as I could. I mean, I did cut out a few bits from this script because otherwise it would have been almost a 3 to 4 hour video. And yeah, I mean, this is a Starfighter. It's been an aircraft that has sort of held a place in my heart since I was, what, 7, 8 years old, when I first saw that photograph of the Italian Starfighter in that magazine. And I really actually thought it was an Italian aircraft. And as I read it, it was like, oh, well, this is an American machine. But hey, you know what? To me, it's an Italian aircraft because it's got the Italian colors and it's flown by Italian pilots. It was always Italian for me. And it just looked right. It just looked like a Ferrari or a Lamborghini with wings. And if you were to give a Lamborghini or Ferrari wings, that's what it would look like. So I really hope you've enjoyed this episode. I know I'm rambling here, but it's been a long day of me narrating and editing. I just thought I'd ramble a bit here. So if you've enjoyed the video, please, leave a like, leave a subscribe, and even comment, whether you liked it or not. And just leave a comment. It's always good for the algorithm. And yeah, so I'll see you for the next one, which is coming very soon after this. So yeah, until then, I'll see you guys. Take care.